Hello everyone, welcome to lesson 31, and we are talking about like terms and things like that, adding like terms. So we're going to do our little startup at the beginning of the lesson. Number sense. 17 people have $200 each. How much money do they have all together? So we're going to take $200. Oops, I need to get my little drawing tool here. We're going to take $200 and we're going to, since each person has $200 and there are 17 people, that is a multiplication problem. So we're basically going to multiply 200 times 7, which would be a 0 and a 14, and then move over 1, and 200 times 1 is just 200. And we move over because that 1 right there is really a 10. Okay, so that right there is really a 0. We usually just don't write it down. And then we get a 0 and a 0 and a 4 and a 3. So $3,400 all together. Fractions. Okay, so we were in class and Braden thought very quickly to just multiply this by 5 and this by 5. So we're basically multiplying 5/4 by 1 in the form of 5 over 5, which meant this was 25 and this was 20. Okay, the other way to do this problem is to use our cross multiplication. So we would say 5 times x must be equal to 25 times 4, and the easy way to do that is 5x is 100, which is 20, or we could just divide this side by 5, divide this side by 5. Since the 5 goes into the 25, I can cancel those, and 5 times 4 is 20, just like we got before, and that gives us x is 20. Fractional parts. 75%, in my mind, I would write this as 75 100ths, which is then multiplied. The of, remember, is always times $200. And we could do this two ways. So since the easiest thing is just to go 200 to 100 is 2 to 1, and 75 times 2 is 150, so $150. The other thing that would be very easy is just to say 75 100ths is the same thing as 3/4, and 3/4 of 200 is 150. Measurement. How long is the paper clip? If 10 paper clips are placed end to end, how far do they reach? So basically we have 1, 2, 3 centimeters. So the paper clip is 3 centimeters long. And then we're going to take 10 paper clips. So we take 10 times 3. So that would be 30 centimeters. Okay, and the next one is rate. If the space shuttle orbits Earth 16 times a day, how many times does it orbit in 2.5 days? So we have 16 times 2.5. Well, we can break that up and say that's 16 times 2, which is 32. And then 16 times 1/2, which is 8. And we add 32 and 8 together to get 40. 40 times around. Okay, now today in class, we were talking about this one. This one is 90, remember? Now the way I do it in my head is I know there are 180 in a triangle, because I like to keep my numbers small. 180 in a triangle. Take away the 90 that is the right So I have 90 degrees left to go between this one and this one, because the 90 has already been taken away. 51 plus what is 90? And the answer is 39, or 90 minus 51 gives you the answer. All right, so roots and powers, we're estimating. So some of you went a little, you worked too hard on this. When we're estimating, we're trying to find something close. We know that the square root of 100 would be very, very close to the square root of 99, and the square root of 100 is 10. We know the square root of 80 is very, very close to the square root of 81, which is 9. And 10 minus 9 is 1. So the estimate would be 1. And this one is fun. I love these. So 45 take away 40 is 5, times 2 is 10, plus 1 is 11, times 6 is 66, take away 2 is 64, square root of that is 8, times 3 is 24, plus 1 is 25, take the square root of that is 5, minus 10 is negative 5. Those are just plain fun to do. Okay, recall that integers include the counting numbers 1, 2, 3, the opposites of the counting numbers, negative 3, negative 2, negative 1, and 0. In this lesson, we show examples of adding integers. We see integers on thermometers, on the Celsius scale. 0 marks the freezing temperature of water. Negative numbers indicate temperatures below freezing, and positive numbers indicate temperatures above freezing. So on the Celsius scale, 0 is freezing. So example 1, if the temperature in the morning is negative 4 degrees, but increases 10 degrees by noon, then what is the noontime temperature? Okay, so we started at negative 4 degrees. We increased by 10 degrees. So how do we figure this one out? Well, let's do this one on the number line. Here's 0, and here is negative 4. Okay, so we know that's negative 3, negative 2, negative 1, and we're going to go 10 in the positive direction. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we end up at 6 because that's 1, 2, 3, 4, 5, 6 steps after we pass the 0 mark. Okay, so what we're going to be talking about is rules for these. And the rules that I'm trying to teach you is if we have same signs, we're going to add the absolute values. If we have opposite signs, we're going to subtract the two absolute values. 10 minus 4 is 6. And then we take the sign of the greater valued number. It's kind of like a tug of war. Okay. Okay, so when we're talking about this, we are, let me get this back in here. I want to get a little bit darker marker here. All right, so when we're talking about this, we have 10 and negative 4 that we just did. The absolute value of these numbers is what we're comparing. So the absolute value of a negative 4 is 4. And the absolute value of the 10 is 10. So when we're saying the greatest absolute valued number, it's 10. Okay, so 10 is greater than 4, and that one's going to pull the hardest. Now, let's just do this one like we did on the number line. So that's what we did on the last screen. We started at negative 4. Okay, so this is negative 3, negative 2, negative 1, and then 1, 2, 3, 4, 5, 6, 7, yada, 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 and this is 0. Okay, so when we're starting at negative 4, here we're going to end up going 10 steps in the positive direction, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we've gone 10 steps, but this number that we are now on is 6. 1, 2, 3, 4, 5, 6, past 0. And that is basically 10 take away 4 is 6. Okay, so the next one, Sam has no money and owes a friend $5. So he had no money to start with, but he owes a friend $5. So we're going to put him down as a -5. If Sam earns $15 washing cars, so earning would be to the positive, then he can repay his friend and have money left over. Write an equation for this situation and find out how much money Sam has after he repays his friend. So it would be 15 take away the $5, right? So that's going to be $10. If we're looking at it as an addition problem, because these are opposite signs, we're going to actually subtract 15 take away 5. We're subtracting the absolute values of the numbers. The absolute value of -5 is 5. The absolute value of 15 is 15. 15 take away 5 is 10. But then, scratch that. That was just work. Then we go back and say, well, is the negative number or the positive number have the greatest absolute value? Well, 15 is the greatest absolute value. Therefore, we're going to give the number the sign of the greatest absolute valued number. It's like a tug-of-war. This guy pulls farther onto his side of the number line, therefore the answer is positive. Okay, so here they're showing the answer to that one just like we did. Now, look down here. We can show the addition of integers on a number line. We start at 0. Positive integers are indicated by arrows to the right and negative integers by arrows to the left. Here we show 3 examples. So we have -3 and +5. So we started at 0. We went -3 steps to the left and +5 steps to the right, and we ended up at +2. Okay. So +3, we started at 0, we went +3 steps, and then from there we went -5 steps and ended up at -2. And -5 starts at negative, well, it was 0, and then went 5 backwards, and then 3 more backwards, and we end up at a -8. So let's talk about the rules which we're about to have. These two have the same sign. Notice because they have the same sign, they're not doubling back on each other like this one had a negative and then a positive. This one had a positive and then a negative. So aren't those two canceling each other out? So that's why we end up doing a subtraction. 5 minus 3 is 2, okay, and 5 minus 3 is 2. But on this one, because the 5, which was the greater absolute value, had a negative sign, then this is going to have a negative sign because the greater absolute value number pulls harder into its zone. Okay, so the negative pulls it to the left, the positive pulls it to the right. This guy's stronger. Okay. -5 and -3 are both pulling in the same direction. So we actually add the two absolute values together. Remember, this is an absolute value of 5, and this one has an absolute value of 3. 5 plus 3 is 8. We add them together, but then we take their common sign, which is negative. Okay, and that's what happens when we do it on the number line. Look at number sentence A and B above and answer these questions. Do the add-ins have the same sign or opposite signs? Okay, well, on A and B, they had opposite signs, negative, positive, positive, negative. Okay, how can we determine whether the sign of the sum will be positive or negative? So when we're looking at it, we're going to look at, say, what is the biggest absolute value? This one has a +5, so the sign will be positive. This one has a -5, which is a greater absolute value than the 3, so the answer is going to be negative. Okay, and then the third question, how can we determine the number of the sum? The number of the sum is going to be the subtraction of the absolute values if we have opposite signs. So we're just looking at A and B right now, and the subtraction, 5 minus 3 is 2. 5 minus 3 is 2. That's how we determine the number value of the sign, and then we have to number value of the answer, and then we have to add, decide which one of the signs to take. Okay, so now look at number C and answer the same 3 questions. Then try completing the sentences. Okay, so in C, it says, okay, do the addends have the same sign or the opposite sign? Remember in C, they had the same sign. Okay, and then how can we determine whether the sign of the sum will be positive or negative? Because they are the same, they're both pulling in the same direction, it's going to be the same as, it's called the common sign. What they have in common. How can we determine the number of the sum? We're adding the 2 absolute values together, and then we're taking the common sign. Okay, so here it says find each sum. We have a negative and a positive. That means we're going to subtract between. So since we have a negative and a positive, we will subtract the 2 absolute values as we do with opposite signs. 6 take away 2 is 4. And then we look and say which one of these is the higher absolute value, and that will be 6. And 6 has a negative sign, so this is going to have a negative sign because the 6 is pulling farther to the negative direction. So the answer is -4. Move over to this one. We have opposite signs again, a plus and a minus. So we're going to subtract 6 and 2 and get 4. But this time, the highest absolute value is 6, and it is positive, so the answer will be positive 4. Okay, down here we have 2 same signs. They're both negative. Same signs we add, and so we're going to get the absolute value is 6 plus 2 is 8. We add those together, and then we look and take the common sign, which is negative. Then over here we have opposite signs, so we subtract and get a 0. 6 minus 6 is 0. One is pulling in the negative direction, one is pulling in the positive direction, the same amount, so we end up with a tie in the tug-of-war. So here they're going through each one of those that we just went through here and got the same answers. All right, so recall that the opposite of a number is also called the additive inverse. We can change any subtraction problem into an addition problem by adding the opposite of the subtrahend. So, for example, instead of subtracting 2 from 6, we can add -2 to 6. So here they have 6, take away 2 is 4, subtract 2 from 6, or we can say 6 plus a -2. So we're taking this minus sign and we're attaching it to the subtrahend. We're changing the sign, which was positive, to a negative. Or just think of it as attaching. Attach the negative to the number behind it and just add the 2 together. Opposite signs, we subtract. 6 minus 2 is 4. Take the sign of the greater valued absolute value. We use this concept to change subtraction of integers to addition of integers. So here we go. We're going to look, this is only addition. So if we have a subtraction, we're going to do what we just saw in the last slide. We're going to change the subtraction to an addition problem. And once we change the subtraction problem to an addition problem, then we'll be able to use these 2 rules. Now, my 2 rules that I wrote on the board today is if we have the same sign, add the two absolute values, and take the common sign. That's it. If we have the same sign, add the two absolute values and take the common sign, because both of the signs are the same. Okay, if we have opposite signs, we're going to subtract the two absolute values. So when we're doing absolute values, we are we're going to subtract the two, or that didn't come out very good. Subtract the two absolute values and take the sign of the larger of the two absolute value numbers, because that one is like a tug-of-war, is pulling harder in its direction. Sign of greater absolute values. Okay, so like I say, this is like a tug-of-war, and the tug-of-war, if you're on a tug-of-war and you were seeing all these people lined up on both sides, if you had this big giant on one side, then that team's probably going to win, right? Especially if you're just a tug-of-war of two and one of them's a giant, he's going to win the tug-of-war. So the greater number, absolute value number, is going to pull harder in its direction. So we take that sign. All right, so let's look at these. To find the sum of add-ins with different signs, so we're talking about this one down here, subtract the absolute values of the add-ins. We're going to subtract the absolute values of the add-ins and then take the sign of the add-in with the greater absolute value. Sign of the add-in with the greater absolute value. Okay, now what I do when I'm doing this with students, because I want something that's going to be easily remembered, I just say sign of the big guy. Sign of the big guy, because he's going to win that tug-of-war. Whatever direction he's pulling is going to win the tug-of-war, isn't it? Okay, and then to find the sum of add-ins with the same sign, add the absolute values of the add-ins. So we're going to add, same sign, add, take the sign of the add-ins. We're going to take the common sign. They should have the same sign because we started out with same sign. So we're going to take their common sign. So same sign, add, take the common sign, opposite sign, subtract, take the sign of the big guy. All right, so collecting like terms. An algebraic term is an expression that includes a positive or negative number and may include one or more variables. Here are some examples. 3y, x, negative w squared, 3x squared y, negative 2. The number part of a term is called its numerical coefficient, or just coefficient for short. Each of the first four terms has a coefficient that is positive or negative number. Okay, so the coefficient of 3y, which they got from this last slide, okay, the coefficient of 3y is the 3 that is on the front. So it is a positive 3. Since it has no sign, it's positive. The numerical coefficient of x is 1. Now, when we see a number sitting here, x, and it has nothing in front of it, then it's understood that it's 1x, okay? And that is positive 1x. So the numerical coefficient of negative w squared is negative 1, because there's nothing in front except a negative sign. We assume that is negative 1. And the coefficient of 3x squared y is a positive 3. Notice that if the coefficient is 1, it is not written. It is understood to be 1. A term without a variable such as negative 2 is called a constant. Okay, so in other words, a number without a variable is a constant. Okay, and here it just says identify the numerical coefficient of each of these terms. Since there's nothing in front of a squared b, that's just going to be a positive 1. 3y is a positive 3. And negative x squared is a negative 1x squared. And they tell you those there. We can identify like terms by looking at the variables. Like terms have identical variable parts, including exponents. The variables may appear in any order. So like terms, negative 5xy and yx, because remember, multiplication is commutative. xy and yx are exactly the same term. Order does not matter in multiplication. Now, it does not have to have the same coefficient in the front. The coefficient in the front is not important in adding like terms. So like terms are xy and yx because they have the same variable parts and the same exponents. They're both just exponents of 1. Unlike terms would be these, not because there's a 2 and a negative 5, but because there's an xy and an x squared y. So that x squared y is really an xy, isn't it? So likewise, 2xy and 2x squared y are not like terms. I think that would have been a better example, because whether they're like terms or not has nothing to do with their coefficient in the front. It has everything to do with their variable parts. Okay, so it did not matter that this was a 2 and a negative 5. That's not what made them unlike terms. What made them unlike terms is that this one had an x and a y, and this one had an xy. Okay, so why are negative 5xy and yx like terms? Okay, why are 2xy and negative? We just talked about that one. Okay, so they're given expression. The xy and the yx are not different from each other. They're just in a different order, which doesn't matter. And here we could change this to be the same look as this one. And then to add them, we would just say, okay, they're like terms. And so all we would do is add their coefficients together. Negative 5 plus 1 is negative 4. So the answer would be negative 4xy when we add the two together. Okay, example 5. Simplify this expression. So we've got 3x, and there's another like term with 3x, and then the 2 and the 3 are like terms together. They're called constants. So 3x and a negative 1x. So once we discover like terms, we put their coefficients in front. 3 plus a negative 1 is 2x. And then we look for the constant terms. 2 plus 3 is 5. And 2x plus 5 is the answer. And there they're showing you there. What is the perimeter? Remember, perimeter is the distance around. So if this one's going to be 2x to match this other side, and this one's going to be 3. So the perimeter would be 2x plus 3 plus 2x plus 3 again. Okay, if we were adding them in order, the 2x and the 2x are the same like terms, so we add the 2 and the 2 together to get 4x's, plus the 3 and the 3 are both constants, like terms, and we add those together. 4x plus 6 would be the perimeter of the triangle, which they show you there. Now we're on our practice set. So we're going to have negative 12 plus a negative 3 is, with same sign, add. 12 plus 3 is 15. Take the common sign is negative. Here we have a negative and a positive, opposite sign, subtract. 12 take away 3 is 9. we take the sign of the greater absolute valued number. So negative 9 is the answer. 12, negative 3, opposite signs. We subtract 12 minus 3 is 9. We take the sign of the greater absolute valued number, positive. It pulls it farther to the right. Negative 3 and a positive 12 is going to be positive 9. Notice that all they did between these is they switched the order. 12 plus a negative 3 plus a 12. Choose any of the problems A through D and show the operation on the number line. Okay, so let's go back to this one. Let's do negative 12 plus a negative 3. So I'm going to negative 12 is right here. Okay, so we're going to move this direction, negative 12. And then 1, 2, 3 more in the negative direction. So when we wind up at negative 15. Okay, so let's do another one of those. Let's do one that has opposite signs. Okay, so we're going to do this one right here. And we're going to start here at 0. We're going to go negative 12, which you can count them out on your paper. But then negative 12 and then positive 3. So 1, 2, 3. And I'm going to wind up 3 steps to the right at 9. Okay, so negative 9, excuse me. Let me get my little marker here. At negative 9. So negative 9 is 3 steps to the right. So we are still, since that was 12 steps to the left, and then we went 3 to the right, that is 9 steps to the left, which is negative 9, which is what we had right there. So we can always do any of these on the number line. E, choose any of the problems, which we just did, 2 of those. At 6 a.m., the temperature was negative 12 degrees Celsius. By noon, the temperature increased 8 degrees. Write an equation for this situation and find the temperature at noon. So at 6 a.m., it was negative 12 degrees Celsius. That is really cold. Okay, and by noon, the temperature had gone up 8 degrees, so plus 8, and we could write that opposite signs. So we're going to subtract 12 minus 8 is 4, but the greater of the 2 absolute values is negative. So negative 4 degrees. It is still at negative 4 degrees, which is 4 Celsius degrees. Remember, 0 is freezing in Celsius. The hikers started on the desert floor, 182 feet below sea level. After an hour of hiking, they had climbed 1,018 feet. Miss A said that wrong. 1,018. Remember, we don't put an and in the middle of a number. Sometimes I boo-boo. Write an equation for the situation and find the hiker's elevation after an hour of hiking. So after an hour of hiking, they had climbed. So negative 182 plus, because that's below sea level, we'll start with negative 182. We're adding 1,018 feet. Okay, they had climbed that much, so that would be going in a positive direction. And let's see where they are. Since they're 2 opposite signs, we're going to subtract 1,018, take away 182. Okay, so 8 minus 2 is 6. We're going to have to come over here and do our renaming thing here. 11 minus 8 is 3. 9 minus 1 is 8. And we get positive 836. So, oh, that's not degrees. What am I writing degrees? That's feet above sea level. Okay, so because it's above sea level, it's positive. Okay, collect like terms. Now, notice that we have an x, y, and an xy. Those two are like terms. We have an x and an x right there. So these two go together. This is an understood 1. 2 plus 1 is 3 xy. And then 3x and a negative x would be a negative 2x. Okay, so now that answer would be correct if I put 3xy minus a 2x or negative 2x plus 3xy. It does not matter as long as I have the correct sign in front of each number. So here, there is not another x squared, but there's an x and an x here. So we have two that are like. This one's a constant, so it's going to be by itself. So we'll have 6x squared. And then we're going to put these two together, a negative 1 and a positive 2. 2 minus 1 is 1, so we're just going to have a regular x, 1x, minus 1 is the answer. J. We have an a cubed and an a cubed over here, and then we have a b and a b. So a cubed, this is a 1 here, negative 1, so 2 minus 1 is 1a cubed. We don't have to put the 1, and then a 3b and a negative 4b is going to be a negative 1b. Again, we don't have to put the 1. Okay, so here we need to look at what is like. So we have an x, x, a y, and a constant and a constant. Okay, so let's go with, we'll get a different color here. So we have x and x. Let's do that first. Positive 1x and a negative 1x. So won't those just cancel out and be 0? So we don't even have to write those down. Those are just going to cancel out. Then we have a positive 1y and a positive 1y, which will end up being a 2y. And then we have a negative 1 and a positive 1, which will end up being a 0. So our final answer is just 2y. Okay, so here we have L's the same and W's the same. L plus L is 2L, twice length plus twice width. Okay, M. P, perimeter, is side plus side plus side plus side is 4 sides. So 4 times S, 1S plus 1S plus 1S plus 1S is 4S. And connect, what is the perimeter of this rectangle? So this one is going to be X, and this one's going to be 3Y because they're going to match what's on the other side. So we're going to have 3y plus x plus 3y plus x. So our 3y's are like terms, and we're going to get 3 plus 3 is 6y, and 1x plus 1x is 2x, and 6y plus 2x is the answer to that one. Now we're actually on your problem set. Those that we just finished doing was your practice set. Now we're on your problem set. I'm going to do the first 6 problems for you. The Acme Scrap Metal Company pays 45 cents per pound for aluminum cans. Troy wants to sell 54.2 pounds of cans. How much money should he receive? Each can is 45. Now that's pounds and that's pounds. So 45 cents, 45 cents per pound. Okay, so this is a multiplication problem. And we have decimals. But remember, when we're doing decimals, we're going to multiply like normal and then go back and put, notice I changed the cents to 0.45 of a dollar. so that I will have dollars when I get out. So 2 times 5 is 10, carry the 1. 4 times 5 is 20, plus 1 is 21, carry the 2. 5 times 5 is 25, plus 2 is 27. Then I've got 2, this one's done. 2 times 4 is 8, we move in 1. And then 4 times 4 is 16, and we carry the 1. 5 times 4 is 20, plus 1 is 21, and then we add all these together. So we have 0 plus 0, and then we have a 1 plus an 8 is a 9, and then we have these two, 7 plus 6 is a 13, carry the 1, and we get a 4 in that column, and then a 2, and 1, 2, 3 decimal places. Okay, now $24.39. Now, because this is a 0, that I would have had to round it, but because it's a 0, I can just knock it off because it's not a significant 0, is it? Now, check it. Is this going to be reasonable? 45 cents is close to a half. Half of 54 would be 28, and this is just below 28. So it is a reasonable answer that we have gotten. Okay, and then a recipe for chili calls for 4 1/4 pounds of beans. Aza wants to make 2 1/2 times the recipe. How many pounds of beans will she need? Okay, so she's got 4 1/4 for one recipe, and she's going to 2 1/2 times the recipe. Okay, so the easiest way to work with fractions is to turn them into improper fractions. 4 1/4 is 16 plus 1, or 17/4. Okay, and 4 plus 1 is 5 halves. Okay, so we're going to wind up with 17 times 5 over 4 times 2. 8 goes on the bottom. And 17 times 5. 7 times 5 is 35. Carry the 3. 5 times 1 is 5 plus 3 is 85/8. Okay, how many pounds is she going to need? Now, 85/8 is more than 10. Okay, but it's not 11 yet. So we are going to say she needs 11 pounds. Okay, if we're doing a general. Now, if we want exactly how many pounds she needs, we would divide. 85 divided by 8 is going to go 10 times with 5/8 left over. Okay, so 10 5/8 pounds is exactly. If you're just looking to purchase pounds of beans, this would probably be, because you're not going to get pieces and parts normally of beans. Okay, so 10 5/8 is the exact. All right, so the atmosphere that we live in is 78.08% nitrogen and 20.95% oxygen. What percentage of the atmosphere is made up of nitrogen and oxygen? Okay, so in other words, when you add these two together, you do not get a 100%. So 78 plus, we're going to write these together and add them, 78.08%, and then 20.95%. Okay, so we add these together, we get 13, carry the 1, 10, carry the 1, remember when we're adding, we're bringing the decimal straight down, and then 9, and 9, and this is going to be 99.03%. Okay, so 99.03%, or 99.03 parts out of 100. Okay, so what percentage is 99.03? And Marcia developed a roll of film and received 4-inch by 6-inch prints. She wants to have one picture enlarged to an 8-inch by 12-inch print. what kind of transformation is this and what is the scale factor? Okay, so she's going from 4 by 6 to an 8 by 12. Okay, so isn't she doubling the size? Okay, so she is multiplying by 2. Now, this is an enlargement or a scaling. This is an increasing. Okay, now it's actually doubling the size of both of them. Now, question, since I'm doubling, the scale factor is 2. If I were talking about what the area is of those two, remember 4 times, it's going to be 4 times the area. Let's check. 4 times 6 is 24. And 8 times 12 is 10. Let's see, 8 times 12. Hold on. That's going to be 16. And, oh, it's going to be 96. 96. All right. So 96 is 4 times 24. So area is going to increase by 4 times, but the side lengths will be doubled. Okay. And number 5, in 1875, an estimated 12.5 trillion locusts appeared in Nebraska. Write the number of locusts in scientific notation. Okay, so we have 12.5 trillion. Now let's think about what a trillion is. Okay, so we've got, when we're looking at it, let's see how many zeros we would. So what we want to do is we've got to figure out where to put our commas. So 1, 2, 3, comma. Okay, so that's thousands. And remember, that's thousands, 10,000s, 100,000s, and 100,000s is the same as a million. And then the comma here would be a billion. And so we need 3 more, don't we? And then that would be 1 trillion. Okay, 6 is a million. So that would be 1 million and billion and trillion. I have to go through and put them all there. So we're looking at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 zeros. So we'll say times 10 to the 12th. Oops, I put 12 to the 12th. That's not what I meant. 10 to the 12th. Okay, so now remember when we're getting it in scientific notation that we want this number to be between 1 and less than 10. So we have to move this decimal 1 to the left, which means we're going to have to move this number 1 to the right. Okay, so our final answer is 1.25 times 10 to the 13th power. All right, that's a big number. Okay, and last problem, Patrick has 7 tetras, 4 goldfish, and 22 snails in his fish tank. What is the ratio of snails to goldfish in Patrick's fish tank? So we have snails is 22 to goldfish, which is 4. Okay, so that is the ratio, but we always simplify ratios. So we're going to divide by 2 and get 11 to 2. And 11 to 2 would be the simplified ratio, which is the last problem on our PowerPoint. So we are done with lesson 31, and you have all of your practices and all of the first 6 of your written set done for you. I hope that you will look at this video and get the answers. This is Mrs. A, and may God bless your day.